Okay, so we answered a couple of false starts. Not everybody seems to have gotten this. Now, when you do one of these, you really want to be real explicit about what everything means, so you don't forget what anything means. Okay, so you want to say like X equals. Well, you could either let X be the grandson's age or the daughter's age. Question ask what's the daughter's age, and everything is in terms of the daughter's age, 1/4 of the daughter's age, 3 less than 1/4 of the daughter's age. So and as soon as you got the daughter's age, as soon as you know what X is, write every relevant quantity in the statement in terms of that age. Okay, so you got to say, okay, well, then 3 less than 1/4 of my daughter's age. I'm going to write this as a parentheses 1/4 X, because a lot of times, if you have a fraction times X with no denominator on X, the X will migrate into the denominator. It's real easy to do that, and I see that a lot. So you want to be careful about that. But then 1/4 X minus 3 would be the grandson's age. And I think that's pretty obvious, everybody, exactly what the problem says. Then you want to say, really carefully, before you write an equation, you want to write what the equation says. So the equation says something very simple. Grandson's age plus daughter's age equals 57. That way, you'll write this as one-fourth of X minus 3 plus X equals 57. I think everybody's got that, but let's make sure that we see, grandson's age is here. Daughter's age is here. In one paper, I saw 1/4 X minus 3 plus X over 4. Okay, it's real easy to make that sort of mistake. You did a 1/4 X here, you can do an X over 4 there, without stopping to think that no, my daughter is not 1/4 of her age, she is her age, okay? And the point of that is, obviously everybody knows that my daughter's age is not 1/4 of my daughter's age, but you match it up with the words you have here. So we put down some words. Grandson's age plus daughter's age equals 57. Then we're very careful to put grandson's age here, daughter's age here. And once we do that, it's easy to solve the equation. So I'm not going to go through the details, except I will try to reinforce this one idea that it's probably easiest to solve this equation if you multiply both sides by 4. Then you get rid of the denominator and you don't have to worry about fractions. So if we multiply both sides by 4, well, that means every term is going to get multiplied by 4. So we multiply every term by 4, and we get X plus 4X equals 228. Uh-oh, I lost the 3. And the other thing you don't do is write things down carelessly, okay? Same thing I was talking about up here. If you write down the equation without writing out the words, you're actually being a little bit careless and you're taking a chance. Okay, let's write it out correctly. Okay. And it's not x plus 5x. I'm going to get 5x. And that's what I was thinking. I was adding the x to the 4x already. You're going to get 5x here, and you're going to get 240 here. Yeah. And you divide that, and you get 48. Okay. That's my daughter's age. And then 1/4 of 48 is 12. You subtract 3, you get 9. His grandson's 9. Daughter's 48. I did fudge that a little bit, and I'm getting in big trouble if my daughter sees this because she won't be 48 until her birthday in about 3 months. So I'm kind of anticipating that. But I had to make the numbers come out right. Okay, now, covering myself, in case my daughter sees this, I didn't give you real accurate information. Okay. Then it'll be obvious if you look at me, and I didn't ask you to find out my age. Okay. But you went ahead and did it anyway. And if you look at me, you realize that I'm older than what the result is going to be. Okay. So I won't tell you what the real sum of our ages is. Because I don't want anybody to know I'm 75 years old. Okay. You know, because everybody thinks I'm in my 30s. Well, no, that's not so. Okay, son-in-law, 21 years younger. So let's see. Now, some people chose to let X equal my age, but and that's fine because you're going to be able to find both ages, no matter which age you let be X. But since I asked how old is he, a lot of times the natural thing would be, well, we'll let X equal what we're looking for. And then we write the other thing in terms of this. So my age plus his age is 96. Let's look like the word this, so put parentheses around these. My age is X plus 21 plus X, and that's 96. Well, that gives us 2X plus 21 is 96. 2X is 75, so X 37.5. And then X plus 21 is 58.5. Well, we're both older than that. Okay, I gave you the wrong sum. So I added 21 to my age rather than adding his age to my age when I did that. That's okay. We'll let his age remain a mystery. Although not really if you listen to everything I said. Okay, let's look at another one. Okay. So what we immediately saw was at L. Well, first of all, as to be recommended, everybody drew a rectangle. And then we have W here and L here, width and length. Okay. The information we're given is that the three sides you fence are going to total 4,000 feet. So the three sides that get fenced the total length to W plus L. Now we kind of have an implicit assumption that the longer side is going to border the river, but that might not be the case. We'll find out that it is, but let's see how it works. Okay, so we got 2W plus L, and that equals 4,000. Okay, now let X equal your width. Two X plus L is going to be 4,000. So L is going to be 4,000 minus 2X. Now, some people did it this way. L is 4,000 minus 2X. And X was the width. Some people let X be the length, in which case you have 2W plus the length equals 4,000. You solve that for the length, for the width, and you're going to get 2,000 minus X over 2. So either way, you come out with expressions for the length and the width. Now we're interested in the area. So we write down area equals length times width. So the area is 4,000 minus 2X multiplied by X, which is 4,000X minus 2X squared. And we want to find the maximum area. Now that gets a little tricky until you realize that this is a quadratic expression. And if we graph 4,000 minus 2X squared, we're going to get a parabola that opens downward. We're going to have a vertex. And the values that we get in that parabola, the Y values essentially are the areas. So the tip, the vertex of the parabola tells us what the maximum area is going to be. So that's a kind of a sophisticated application. So we're going to do that. Before we do that, Okay. If we took 4,000 feet of fence and wanted to fence a rectangular area with the maximum possible area, we'd do a square. If we didn't have that river there. And we put this into a square, it'd be 1,000 feet on the side, it'd be 1,000,000 square feet. Okay. Now, since we got the river, we can do more than 1,000,000 square feet. We're going to find that out. For this situation, if the area is 1,000,000, let's see if we can take this knowledge. I'll just use A for area. Okay, we've got a function actually. Gives us the area is a function of X. What if the area is 1,000,000? What would L and W be? Okay, so well, the obvious thing to do here is put 1,000,000 in for A. Well, then you can subtract 1,000,000 from both sides, and you would get this, obviously. Why would you do that? Well, because you have an X squared and an X here. You have a quadratic equation. Now let's put this equation in more standard form. And I'm going to do what everybody seems to have done. Put it into this form. And then in this form, you could use the quadratic formula. And if you use this form, you could use a quadratic formula equally well when you have it in this form. You really kind of want the X squared and the X, the constant number in order, because it's a little easier to get everything right if you have everything in the expected order. And when I wrote this, I chose to make the 2x squared positive, and then the 4,000x would be negative, and the 1,000,000 would be positive. Okay. In other words, I multiply all this by -1, then switch the sides. So it's a little easier if you notice that everything can be divided by 2. Your numbers are just a little smaller. So when you square 2,000, it's a little nicer than square 4,000. And then you just plug into the quadratic formula. And the numbers are big. And something's wrong here. Let me just pause and make sure I got the numbers right. I was doing some stuff. Thinking ahead a little bit. Okay. And something wasn't working out because I wasn't looking at it right. Okay, now the square root, 2,000 squared is, no, it isn't right. I'm getting a negative under the radical.
Only okay.
Actually, probably not. Anyhow, okay, well, let's see where we end up here. Okay. This is going to be 2 million. That's going to be 4 million. So you've got to get 2 million there. Okay, 2,000 over 2 is 1,000. And the square root of 2 million is like 1,414. Then some more decimals. So approximate this, but it's going to be about 707. When we divide by 2, it gives us 2 possible answers. One of which is like 1,700, which isn't going to work because we got 1,700 here and 1,700 here. That's going to leave us like 600 here. Okay. And the other is 293. So we could have 1,707 here, 1,707 here, and roughly 600, like 1,700 by 1,700 by 600. And now if it's 1,700 by 600, would you get 1 million? Well, for the area. Yeah, you would. Okay. If it was 293 here, 293 here, okay, that would give you approximately 600 here and 1,700 here. Then you'd have like 300 by 1,700, which doesn't give you 1 million. So something's wrong. With this part of the solution, this part kind of works. Okay, so you could have and that would work. It's 293. Disturbs me because it doesn't work, but it should be a solution. 1,000 minus 700 is about 300. But it's like you have something that's approximately 300 here, 300 here. I got the wrong number. 4,000 minus this, it's 3,400. And that works. The area is approximately 300. Don't have room to write that very well, so probably can't read it. But yeah, that checks out. When I did it in my head, it didn't check out. When I wrote it out, I did it right. All right, so that works. Okay. Now that's clearly not the optimal area. It's too long and too narrow, or it's too narrow this way and too long this way. Okay. And of course, it doesn't look like this. It's 1700 by 600. It's going to be a lot longer this one. Let's see what our knowledge of quadratic functions can do to illuminate this. And I notice I can probably I just discovered another button. What did this thing do? Oh, I know what it did. Okay, well, I hope I've got this right. Okay. It flipped the screen right to left. Okay, as I had the remote upside down, I still got it upside down. Well, now I think it looks okay. All right. Okay, so where are we? Let's do this area as a function of x. Let's graph y equals a of x. What are we going to do to graph this? Okay, now everybody seems to understand how we graph this. That was very good. So really going to root there, so let's manufacture the life before space. Oh, okay. Well, to graph this, find the axis of symmetry and the axis intercepts. The axis of symmetry, well, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Your axis of symmetry, as was astutely pointed out, well, you can find the axis of symmetry by finding the zeros. And the axis of symmetry will be halfway between the zeros because that's what symmetry tells you. Halfway between the zeros is negative b over 2a. Because negative b is halfway between negative b plus this and negative b minus this. I need to know that indicates the axis of symmetry is at negative b over 2a, which is going to be what? Well, b is what's in front of x, and that's 4,000. A is what's in front of x squared. That's going to be 4,000 over 2 times, which is, and it's the negative of, so that's 4,000 over 2 times negative 2. In any case, that comes out 1,000. Okay, well, that tells us something already about the scale of the graph. Right here's our axis of symmetry. So the parabola is going to have a vertex on the axis of symmetry. Let's go ahead and find the axis of intercepts. When we do this, we get 0 here for the 4AC. Square root of 4,000 squared is 4,000. So we're going to have 4,000 plus 4,000 over this, or 4,000 minus 4,000 over this. 4,000 minus 4,000 is 0. 4,000 plus 4,000 is 8,000. And it'd be negative 8,000. Now it'd be, yeah, not negative 4,000. Okay, it's 0 or 2,000. Is that consistent with our axis of symmetry? Well, right here's x-intercept is 0. And if this is 1,000, 2,000 is out about here. So these are our axis intercepts. Now our y-intercept happens to be the origin, which means it's also an x-intercept. Ordinarily, when we do this, we're going to get, if we get 2 zeros, we're also going to get a y-intercept that isn't one of those zeros. And that allows us already to do a pretty good graph. Still, we're going to want the vertex. It's an x equals 1,000, so y is what? Y is 4,000x, which is 4,000 times 1,000, minus 2 times 1,000 squared. That's 4 million. That's 2 million. We get 2 million. So the y-intercept is at 1,000, 2 million. Now, if we want to draw the parabola, there we have it. Our conclusion is that the maximum of this occurs when x equals 1,000. And y equals 2 million, which means that our rectangle, going back to our river with the fence, width here, and length here. The width is 1,000, length is 2,000. So the farmer's going to want to do 1,000 by 2,000. Another bonus. Previously, that we did here. We figured out what the length and width ought to be if the area is 1,000. Or 1 million, sorry. Well, when the area is 1 million, here now our area is 2 million. $1 million would be here. What's this? And what's this? Okay, this would be the X that would give us an area of 1 million. We solved for that, and we found that that was about 293. Another solution was about 1,707. In other words, our graph is consistent with our equations because on the scale of this graph, 293 here, about 300, makes perfect sense if this is 1,000. And if this is 2,000 here, 1,707, between 1,000 and 2,000, that looks about right as well. So we kind of want to understand that the picture is consistent with the solution we got for when X for the area is 1 million. And then using properties of the parabola symmetry about the axis of symmetry and the existence of the vertex, we were able to determine the maximum possible area and solve the farmer's problem.